In this video, we're going to find the square root of a number using Newton's method and implement it with a while loop. So before we do that, it's important to talk a little bit about how a computer finds the square root of a number anyways. It's not quite as straightforward as multiplication or division, addition, and subtraction. There's complex ways to figure this out. Many ways have been developed, and the ones that are very fast and accurate are the ones that are used. Isaac Newton, a famous scientist from the 17th century, figured out a simple way of doing this, and that's what we're going to implement, and it's famously known as Newton's method. So the way it works are these steps right here, and essentially the overview is that we're going to keep taking a guess at the square root, updating this guess based on the error, and once the error is small enough, then we will stop repeating and just use that as the estimated square root. All right, so before we begin, we have to have some number that we're trying to take the square root of. Let's just say we're trying to take the square root of 520. And then we can go on to the first step, which is to take a guess at the square root. This can be any number, really, any reasonable number. It doesn't have to be very good at all. Just to show you, I will make a very poor guess over here of 5. So 5 squared is 25, which is far away from 520. We're next going to calculate the error, which is just the guess squared minus the number. This is actually what I just said. So we're going to take the guess squared and subtract the number. So that will be the error. And then the idea with Newton's method is that he figured out a way to update the guess based on this error. So, and the way he updated the guess is by doing the following. So he calculated some value here. So he divided the error by twice the guess. So we're going to do that in just a little bit in our while loop. And then he subtracted this value from the guess. So there's 2 steps here into updating. And once you get the new guess, then you calculate a new error. And if that error is small enough, then you stop. Okay, so you're going to repeat this process of calculating the error, updating the guess, and then checking the error until there is some acceptable mark. So what we're going to do here is we are going to say we're going to allow for a maximum error. So we're going to define some maximum error. This is the most error we will accept. If it's further away from this number, then we will keep updating our guess. Okay, so let's make this quite small, say maybe 0.0001. Right now, let's just print out our error at this moment. It says negative 495. So the initial error, you might want to, what we'll do is we'll say the absolute value of it. And there's a reason for that. So it's 495 away, right? And now we can start our while loop. So we'll say while the error is greater than the max error, like that. So as long as our error is larger than the maximum error, this is what we don't accept. So it's a very small number. Right now it's 495. So while 495 is greater than 0.001, we are going to do this. So it is true right now. So what we're going to do now is update this guess. So I'll call this update. And we're going to divide the error by twice the guess. Okay, so this is the only part that's a little... I'm actually going to calculate the error again. We cannot have the absolute value for Newton's method. This is just to check the maximum error. And I guess I could have put the absolute value over here, but that's fine. We're going to recalculate the error. And to get the update is we just take the error and divide it by twice the guess. So I'm going to do 2 times guess like this. Okay. So I'm putting this in parentheses so it does this first, and then it does the division. And now I'm actually going to do the update. So I'm going to subtract this value from guess. I'm going to do minus equals update. like this. So before we move on, I actually want to change this up a little bit, make it a little bit cleaner. So what I'm going to do here is I'm going to take the absolute value here and remove it from here. That'll allow me to not calculate the error right here twice. So I want to do it after I update. So I'm going to move this over here. So let me go through the change again. So I calculate the initial error over here without the absolute value. And then I'm going to say, what I really care about is the absolute value of the error. I don't care if it's negative or positive. I just want it to be less than this mark right here. So if it's anything greater than this, then it doesn't matter if it's negative 10 or positive 20. Either direction would be a bad error. I want to be very, very close to this number. That's why this absolute value will be used right here. We want the the absolute value of the error. We want it very close. So whether it's 519.999 or 520.0001, we want it to be very close to this number. So that's why we're going to tell us the absolute value of the error, which will always be positive. If it's greater than 0.0001, then it will keep running this code block over here. So the first thing it does is it calculates this update, which is just the error divided by 2 times the guess. And then it actually updates the guess itself. Okay, so we're going to make that update. We're going to change our guess. And then we're going to calculate the new error, which is the same formula over here. So we're going to take the square of the guess and minus the num. And let's go ahead and print this out as we go along. So we'll say, use an F string. So we'll say guess is guess and error is error. So we can see what happens over here. So now let's finally run this. And there's a lot of numbers over here. So we can see that after the first update, it is 54.5. We could actually have this one more print statement up here for the initial one. So before the while loop. So the initial guess is 5. The error was, negative 495. That's why we do the absolute value for the first one. Just because otherwise it would not even go through the loop or go through the while loop. Let's say negative 495 is not greater than the maximum error, so it would say this is good because it's such a low error. But no, it's actually a large error in terms of absolute terms. All right, so it goes from 5 to 54.5. Then here is the error. So it overshoots it. It goes way above it. Then it gets much closer. So the next one is this 32.02. The error is 505. It's actually still quite far away. So 5 is actually still a little bit closer in terms of absolute values. Then, okay, so finally it does get to, so at the next one, at the fourth iteration, 24.13, the error is down to 62. And then the error gets much smaller, down to 1.6 and 0.001. And finally, it's a very small number. You have to see this e to the negative 10th. That means there are basically 9 zeros in front of here and then an 8. So it's 0.00, like 9 zeros and then 8. So this is very, very close to what we want and very close to the actual square root. Okay, so that's how you can use a while loop to find the square root of a number using Newton's method.